Hello and welcome to our virtual lunch and learn today. We're talking about empowering wireless technologies for reliable I/O and IoT infrastructure. My name is Rachel Green and I'm the Digital Communications Specialist here at McNaughton-McKay Electric Company. And presenting for us today will be Joel Austin, Business Development Manager with ESTeem Secure Wireless Networking. Ready to answer your questions in the comments today is Sean Adams, Sales Manager with McNaughton-McKay. He's joining us from Greenville, South Carolina. Feel free to enter your questions in the comments as we go along, and we'll have a Q&A portion at the end for Joel to answer those questions in more depth as well. We'll be getting started shortly, but we'd like to allow a few minutes for attendees to join us here. As you come in, let us know where you're tuning in from in the comment section. You can view recordings of previous virtual lunch and learns on our YouTube channel under the Virtual Lunch and Learn playlist, and we cover a new topic every Wednesday at noon, so be sure to join us on your lunch break. For anyone just coming in, welcome to our virtual lunch and learn today, empowering wireless technologies for reliable I/O and IoT infrastructure. Let us know where you're joining us from. Feel free to type any questions you have in the comment section while our presenter, Joel Austin with ESTeem, discusses industrial communication strategies and modernization. McNaughton-McKay Sales Manager Sean Adams is available to chat with you in the comment section, and Joel will be available to answer your questions during the Q&A segment at the end of the presentation. If you'd like to reach out afterward, or if you have further questions for Joel, you can send us an email at macamaclive@mc-nc.com. Just be sure to let us know which session you attended in that email, and we'll have that email address on the screen for you at the end. We have a few viewers here with us now, so let's go ahead and get started. Joel, I'll pass it over to you.
Thank you, Rachel. Hi, again, I'm Joel Austin, Business Development Manager from ESTeem Industrial Wireless Solutions. And we're going to kind of review a number of things today about our wireless solutions and some technology that's going on out there. But to get things started, I kind of want to just introduce ESTeem for those who have not been exposed to us. We've been around for a little while, since '82. And we are the manufacturer of our radios, obviously, and radios are all we do. In addition to that, we design our own radios and we write our own software, firmware for our products, which puts us in charge of both the hard and soft IP of our product entirely. So what that allows us is a lot of flexibility to deal with applications, update firmware, things like that ourselves, and we maintain complete control over that. Made here in the US in Washington State, and of course, we offer a full package of solutions to include licensed frequencies, unlicensed frequencies, as well as cellular solutions. And we will go over some of those in this presentation as well. And then in addition, we've been over 25 years in the partner program with Rockwell. So to kind of kick things off, we're going to touch on some industrial communication modernization strategies that are out there, sort of review a state of the union of the wireless industry as a whole, and then talk about today's design considerations as well as features for reliability and redundancy. ESTeem, it pretty much addresses markets across the board. So we do everything from AGVs to infrastructure, all the way to water, wastewater, oil and gas mining, so on and so forth. So we have a lot of crossover experience as well that we can bring to the table when utilizing our products. Just because a particular industry hasn't had a challenge doesn't mean we don't have some best practices or some ideas for solutions to cross over those best practices, if you will. But really what this is all about is trying to get this digital transformation thing to happen today. You can see kind of the stepping of technology that has gone on over the years, and now we're well into industry 4.0 or 4.1 that is about has a big component of data collection. And so there's not going to be just one strategy to collect all of this data. There's going to be a blend of technologies. And what it really boils down to is there's essentially four pillars of areas that are for data collection, right? There's the things out on the edges here, the devices, and then there's the connectivity piece in between. And then, of course, you have where is the data going to be stored, and ultimately the visualization and analytics. So what this boils down to is you have the devices out here on your Rockwell devices, either PLCs or just end devices themselves. And then ultimately you're trying to get this up to like a factory talk type system. And then all of the stuff in between where ESTeem kind of lives is obviously in this connectivity piece, collectively comes together as the connected enterprise. Okay. And as a result, we will try to address some of the challenges with that. In this, this is obviously says water and wastewater, but this is industry at large where we're always trying to get out distance or remote places. We've got roads, water, it could be land in between, just long distances. And then there's mobile applications, and then we have significantly remote assets that could be remote pumping stations or remote sites that we want to gather all of this data from. And we've kind of in the past figured out through either radio or lease line, a number of different solutions out there to kind of reach out and touch things, but we also need to do this securely. So that's one of the things we will also spend some time touching on today. But to kick it off at the base, let's just talk about wireless technology as a whole, just kind of the 101 level stuff. And probably one of the first questions I get asked or anybody gets asked coming in, what are the good and bad frequencies should I be considering? Well, unfortunately, there isn't a good and bad. There's right and wrong, but that depends on the overall application, which is why at ESTeem, we typically don't come out of the beginning of a conversation talking product because we don't know what product you would really best fit your application, what you would need. So we have obviously a package of products that will allow us to address the number of different challenges or a number of different application desires that are out there. So we have three basic families of products. We have the 195, which is our narrowband licensed. We have the Edge, which is just what it sounds like. It's for your edge access pieces. And then we have the Horizon, which is our broadband spectrum. So down here is really where kind of the 470 and below is where the 195 would live. 900 and above is where the Horizon lives. And then our cellular solution would obviously be the Edge. So some advantages and boundaries that one should consider when going with narrowband is you can see the frequencies here. It's obviously FCC licensed, so you have to go to the FCC and get a license for this, as many people in the past will tell you. It's a fairly easy process, but you have to have a FCC license. That license allows you a greater power level, which allows you better range. You can see 15 to 30 miles of range. And then, of course, as you can see, according to this graphic here, you can see that the frequency offers a lot of line of sight tolerance or terrain tolerance. So if there's some trees or some buildings in the way, think of it more like a fog than a beam of light. This can deal with some obstructions in the way and not have too much trouble. And then the cable and connector losses are pretty low for remote mounting antennas and such. But some of the challenges that you may run into with this is the data rates. If you need more than about 64K of data going through your network or going through that radio link, this might not be the best option for you because it's obviously limited. The higher noise floor means that we just have to have more power to communicate, which obviously the FCC authorizes for those reasons. And then the size of the equipment tends to be bigger, not necessarily the radio itself, but the antennas, the cables tend to be bigger in diameter, those kinds of things. So those are things to consider. You're going to need more space, especially for the antennas. Talking more about specifically the 195 radios, they can have Ethernet as well as serial interfaces. There's multiple modes of operation. So you can have a single radio being both a master and a repeater, or any radio can be any role essentially. So there's not specific part numbers for specific roles that they have. Uh, the PLC protocol emulation is one of those functions that if you need it, you kind of know what it is, but it's basically, it'll emulate being the PLC so that you can use radio in the application for some of those serial applications. And then we also have AES 128. I'm sorry, that's a mistype there. I'll get that corrected. Um, it's 128-bit encryption on this level radio for your security. And then it's obviously simple to configure. We have a Java-based discovery and configuration utilities that are pretty much point and click, and then you can set up any routing tables you may need and things like that. It's pretty straightforward. And then, of course, you've got your 10-mile range and line of sight. Talking about the broadband, this is probably today what is most utilized. And you can see we have 900 megahertz still offered. I will get more why we still offer 900 megahertz in a couple of slides. But for now, we have 900, 2.4, 5.8. And uh, the advantage of that is obviously license free. You can just buy them and start using them today. Higher data rates. Obviously, they fit better due to speed and bandwidth into Ethernet networks a lot easier. These radios can be meshed, so you have fault tolerance and redundancy. And then also we can offer Wi-Fi access through these radios. So some of the complexity that goes into a wireless network is that it is license free. So one of the benefits is also one of the boundaries that you would need to consider. It's shared and dynamic. So you've got to be keeping an eye on not only when you're putting these systems in, but also what might come up in the future. Um, so there's ways to deal with that, but it is something that will have to be monitored over time. The radios, because they are unlicensed and they're meant to be shared, the power levels tend to be down, which means that you may need a couple more radios for repeaters. It's not the end of the world, but it is something to consider when going with this technology. And then it becomes more line of sight. As you can see from the graphic here, you definitely can tolerate a little less in the way, and in some cases a lot less. It just depends on as you go up in frequency, the signal packages get smaller and therefore obstruction becomes more of an issue. In the Horizon radio, it's an industrial mesh technology radio, and we will talk about how our mesh works. Uh, Again, multiple modes. This can be layer 2 bridged or layer 3 routed. It also actually has this time the AES 256 encrypted connections. So it's got a higher level of encryption on there. It is also Java-based configured, so it's really simple to configure. And then there's a memory module on board. So what you can actually do with this radio is not only save your configuration file on your computer and save it inside of storage on the radio, but there's also an SD card that you can access that in the event of a failure, you can tell a new radio to read from the SD card and it will clone everything right down to the IP address in the MAC. All of the programming and everything will just be automatically uploaded. So it allows for rapid replacement of the radios themselves. So as I discussed earlier, our 900, we still have one around, and it's been a long time workhorse out in industry because it's license free and typically was frequency hopping. But many have started to move away from 900 because of its low throughput, something less than a meg. And then it also has some limited topologies where it's a hub and spoke, as we refer to, or a master client type configuration. And then there's uh, standard to no encryption. Okay, and really, it's kind of 900 for a lot of manufacturers is at the end of its branch of utility to them, and as a result, they've moved away into other technologies. But customers out there have no way of seamlessly moving to a new technology. It's pretty much a rip and replace option, and there's nothing out there with any backward compatibility. So talking about our 900, we've actually developed a radio. We've put OFDM modulation on board that allows us to get 72 megs of throughput. And we can do this on 5, 10, or 20 megahertz channels. So we can operate with other 900 in the area and things like that by picking a channel and then reducing the width of our channel to kind of move around some other things that might be operating out there. This is also, we can also make this mesh. It has the 256 encrypted, multiple modes again, layer 2, layer 3, as well as mobile roaming. So you can set the radio in a condition that it will just go out and touch whichever base it's closest to as you move around a facility if you have mobile applications as well. So to kind of discuss the difference between frequency hopping and OFDM, okay, this is what your spread spectrum frequency hopping would look like. It's a number of center channels and we're hopping around sending data as we move. This is what OFDM looks like. And really what you're doing is you're kind of opening a pie and looking at it from the top. So this is like a funnel of data, okay? And we would have to interfere with over 60% of this package before we would start to see data degradation or performance issues. Not going to talk about the 4.9 too much. This is something that's out there. If your customers have it or if you have it, that's great. You're entitled to use it. We have solution for it. If you don't, right now licensing is being discussed between different entities to see how the licensing is going to be handled moving forward. So once that gets cleared up, we will revisit this, but I just wanted to let you know we do have solution for it, but right now it's kind of limited in its application. But moving into the narrowband and broadband discussion again, to kind of give those who are new to RF or want to know a little bit more, if we're talking about a license frequency, the 195, the center channel on that, to give you an idea why it's so restricted from its throughput, is about 1/8 of an inch wide. So it's about the size of a coffee stir straw. Now, when you're talking about our spread spectrum OFDM, it's the equivalent of a 17-foot culvert. So you can see I could put a lot more water through this pipe than I can this one. And that's basically why you get the data throughput difference. And this is another graphic to kind of drive home. Again, we're trying to get on this 20 megahertz channel, we're getting 72 meg throughput, and down here would be the equivalency of a licensed frequency. And what we're all trying to accomplish here is get all of these different data sets through, right? We're trying to get AI and integrate IoT and cameras and talk to maybe cloud applications or up to SQL databases. So we have a diverse amount of data going through, which is why when we're talking about network design, we talk about technology last. When we go into the design, or what I would recommend anybody does, is let's talk about the application demands first. Okay, what are we trying to accomplish? Then let's talk about the terrain or any of the distances, basically the physical challenges that are going to be involved. Once we come to conclusion on all of these, then we can talk about what is the right frequency and what's the appropriate technology. Then from there, it's pretty much a three-step design process, right? We talk about a software feasibility study. We can get GPS points on a Google map, if you will, or Google Earth file, and see what the distances are and things like that. But we don't know quite the topology. We just kind of are looking at this from a out of the box feasibility. And then we can get our anticipated data signal levels and data rates from that. The next step would be, okay, we've decided that theoretically this is feasible. Now let's do an RF site analysis. Okay, so you employ someone to come in and do an actual physical site survey looking at the actual topology of buildings and hills or trees or whatever's in the way, and figuring out how high antennas got to be and those kinds of things, positioning, so on and so forth. And then they will record throughput and provide a report. From there is where installation and commissioning comes in. So now you get the equipment, install it, get everything up and running and prepare to go live and then actually go live. And ESTeem can help with all three of these levels. We ourselves, as well as partners around, which Mac and Mac are one, that can go out and do uh, feasibility, radio surveys, and even help with commissioning. Okay. Now, as far as the RF design, we have downloads on our site that will let you come and grab this software, but we can even be sent the GPS coordinates and we can start this process for you. Um, so it's, you can see it working here. You just plug in the frequency band you're looking to operate in, the antenna gains, the amount of cable, any antenna heights, so on and so forth. And this will calculate everything from throughput to RSSI, as well as issues with the Fresnel zone, which is basically RF lobes. And when it lobes out, if it's striking the ground because the antenna is too close or something like that, we can calculate that out as well. What you're basically looking for is this green area over here. Green is good, red is bad. It's pretty straightforward. And then we can compare different options based on, to start the discussion of where we should build an RF site survey or a radio site survey around. From there, you go to the radio site survey. You can see here, you get spectrum, you get data throughput, and we can read all of that while on site with different antenna positions and different frequencies to validate what we found during the previous step. This gives us a report that you can look at, the customer can look at to say, okay, this is what 900 looks like, this is what 2.4, this is what 5.8 would look like in this particular example. Okay. Again, talking about the design concepts. One of the things we can do is mesh. We're going to talk about mesh a little bit and how it works. So mesh actually has a standard, and it was built around Zigbee, if anybody remembers that. But it was initially developed to uh, basically deal with failure points along a line and get low energy transmitters to transmit out longer distances by essentially transmitting and then transmitting again, so on and so forth. Well, now we use it as a pretty much a redundancy scheme. So what you can see here is we can self-heal and we can actually heal and you can control how the radio heals. So you can set priority of your primary link, your second failover link, your third failover link on each one of the radios. And what our radio actually does is it will go to number 2 and try to transmit on that. Number 3, try to transmit on that, and eventually land on one of them. But it always tries to get back to the primary. So if you've ever had a radio application that for no good reason seems to degrade over time, this is probably why, because some mesh radios out there will move to a secondary link, and then as long as that link is active, they will stay there. Our radios always try to get back to this primary, most efficient path of communication that was deemed appropriate by the analysis, and then the site survey had confirmed it. And our configuration software is pretty much point and click type software. So you can see here, you can configure the radios directly from this software, and then set up how they're going to transmit together by simply drawing lines between the radios. So we link them together, we set up the redundancy paths, and then as this moves forward, you will see the user here will go out, they will click on an individual path, and they will set the priority of that path. So here we go, click, a screen will pop up, and then you can see in the upper left-hand corner right here, they're setting the path length, which is how we determine which is our primary, our secondary, so on and so forth. This software, the same software, can also be used in a monitoring mode. So you can come out and see here where we're looking at the RSSI as well as which channels are blocked and which channels are active. So you will know by your initial design whether or not you're on a primary or a secondary channel and what the performance of that channel looks like as you're reading it. So it's a real-time snapshot. As so this will help in troubleshooting. Nobody knows more than me the heartbreak of looking at a link and seeing a performance problem and then realizing it was blocked the whole time and that wasn't my source problem at all. And then the radios can also output Modbus registers that can be read by every platform out there to integrate into a visualization system to monitor the radios continuously if that's what your application requires. And then finally, we have our Edge Access Plus that allows us a cellular link. So again, we can use this for remote access. It can be bridging the actual network or a point-to-point type remote access utility. It's completely scalable and it doesn't use cloud. It's a virtual VPN access. So you can actually extend one network that you're using locally out to your remote sites and allow those to integrate in as if they're part of the native network. This device also has two SIM card ports, so you can use multiple LTE connectivities. So if you don't like one and you like another better, that's fine. You don't have to have a redundant one, but if the application requires it, you could go between two different cellular services and have one as a primary and one as a backup. Should you lose one, it'll step to the next. The device on board has obviously the LTE, it has Wi-Fi access, it also has copper access. You can use some of these at your leisure or at your choice. Layer 2 bridge, layer 3 routing. It can talk up to the cloud if you would like through AWS or Azure or any of the others, but MQTT access. But and it also has 256-bit encryption over the data flow. So it's, again, very secure. This device is also very flexible, scalable in that you can do a crypto key to a single device so that you have the remote device, the crypto key, connect that key to your computer, have the remote out in the field, and it could be anywhere on the planet. From there, you could have a single access point to multiple points if you have multiple remote sites that you would like to have access to. And finally, through the software, we've teamed up with TossiBox on this product. So through the virtual software that Tosibox offers that can run on a VMware, we can offer multiple devices to talk to multiple devices. And this is completely controllable by the user, by a third party, or by Tosibox themselves offers this as a solution through their virtual box. So it can be as self-managed or as hands-off as the customer would like. And so you can add users, you can delete users out. You can even offer temporary access. For example, if you wanted somebody at ESTeem to look at what was going on with your radios, you could give me time limited access or date limited access, as well as permanent access. And you send me a link, I consume that link when I log on. When I log off, I'm never logged on again, and that key is dead. And then again, anywhere on the planet, we can tolerate access for this. So it can be, again, to the cloud. And what this essentially does is that allows both local access. So you can see here, you have a normal fiber and copper network down here. We have a radio system in operation here. We have our cellular operation here, and it's all blended. Okay, there's no one answer in any specific area. And this is by the virtue, at least on the network side, you know, a great example of the Rockwell Connected Enterprise. Okay, that's my time. I hope it was informative. I thank everybody for their time, and I guess we can open it up for any questions.
Thank you so much, Joel. That was a wonderful presentation. Lots of great information in there as well. We don't have any active questions in the chat, but I'd like to allow a few minutes for anyone that's been holding those questions until the end. While we wait to see if anyone does have follow-up questions for you, I'd like to reiterate that you can reach out to us even after this live stream has ended, or if you're watching this as a recording later, at that email address there on the screen, macandmaclive@mc-mc.com. Just be sure to let us know the name of the session in your email so we can direct your question to the right person. And, while we wait to see if anyone has any follow-up questions for you, we do have some questions that some of our users might have that are some frequently asked questions, and we can go over those for now. The first one might be, do you charge for the software?
No, the software is available for free and download off of our website, esteem.com. So feel free to download and utilize any part of that today, tomorrow. One thing I didn't mention during the presentation was if you would like to start configuring your radios beforehand, the software will also allow you to put in dummy radios essentially and configure those so that when your equipment does arrive on site, you've already got the design worked out and you just have to push the upload to them.
That is great. That's wonderful to know. Another question folks might have is, do you have to use all of the same radios in an application?
Absolutely not. As we talked about with the ending slide with the connected enterprise, um, we can um, we can offer a blended system. So some of it may be cellular, some of it may be terrestrial RF, it may be licensed, it may be unlicensed. It's really about utilizing the right technology for the particular application and the different challenges within that application, as opposed to trying to make customers fit into a, for the lack of a better expression, a one size fits all solution.
Wonderful. And, security is top of mind for everyone these days. What type
Mhm.
of security do these radios have?
Well, we have multiple levels of security. Obviously, there are administrative logons and things like that that we're all pretty much used to these days. But in addition to that, we are running embedded encryption. It is somewhat proprietary over the air on the radio side. So once the data comes in, as we're pushing out over the air, we do within the 256-bit encryption, we are also blending data and carrier and diagnostics. So you would really have to have some time on your hands in order to be able to get the RF signal and decode what is going on in there. The last calculation I heard is it would take you somewhere in the neighborhood of 444 billion days or years. It's once you get into numbers that big, it's just
Wow.
insane.
Yeah. That's incredible. Wow. Well, wonderful. Thank you so much for all of this very useful information. We really enjoyed this presentation and are grateful to have it on the channel. Thank you to Sean for being our resource out in the comment section for us today. And thank you most of all to all of our live viewers here with us today. We appreciate your time. We hope this session was informative and engaging for you. And remember to subscribe to the McNaughton-McKay YouTube channel for more industry content. We look forward to seeing you live again soon. Thank you, everyone. Have a great day.
Thank you.